Okay, we're going to look at this graph and talk about writing a sine function graph for this. So the idea here is you're comfortable with periods, so I imagine that you're able to see what the length of one cycle is, which in this graph is 20. And then amplitude, which it appears that the midline is here at 0, so the amplitude is something like 10. So we're going to talk about putting together the equation from there. So given that the amplitude is 10, that tells us the A value is 10. And given that the midline was still centered around 0, there was no shift up or down, so the K value is 0. So for our equation, we then need to find the B value and the H value. For the B value, it's dependent upon the period. So like knowing that the period is 20, remember how this normally works. We know that if we're looking at a sine or a cosine function, normally the period is 2 pi. Then it's adjusted by the B value, meaning it's multiplied by the reciprocal of the B value, which either stretches or compresses the graph to give us a new period. By seeing that the period in this graph is 20, we know that the new period ends up being 20, and we can solve this smaller equation for B. So we get something here like 2 pi over B equals 20. And then if we cross multiply, we get this, and then I would get B alone. So in this case, B is going to equal pi over 10. So that's the B value that would end up giving me that period of 20. And then now for the H value. So this is a little bit tricky because these graphs do repeat themselves. There are infinitely many answers for this. And what you want to think about is if you're writing a sine function, we normally start the period for our sine function. Okay, the parent function looks like this, where we start at 0, we go up, back to the midline, down, back to the midline, and that starts one cycle of the wave. Now this wave continues to the left and to the right forever, but what we're trying to look for is we're trying to identify one cycle that could be the starting cycle. That could happen lots of different places because it does repeat itself. So for example, I could choose this as a really good starting point to emulate a sine function, because notice if that was the starting point, the function would go from the midline to the maximum, back to the midline, to the minimum, back to the midline. And that looks just like the parent function. Okay. However, I could also have identified this as the starting point. And it goes from there to the maximum, back to the midline, to the minimum, back to the midline. And that again also looks like one cycle of the sine graph following the pattern of the parent function. So either of those places would be good starting places, meaning they would be your H value because you're thinking about them just like you thought about this point in the parent function that was at 0, but it's not happening at 0, it's happening somewhere else. So you're saying, hey, take this starting point, shift it this far to the left or to the right, and that shift left or right is your H value. So if I choose this starting point, that's lined up with an X value of 5. That would make my H equal to 5. If I chose this starting point, that's lined up with an H value of 25. That would make my starting point at 25, and that would be my H value. So either of those would work for a sine equation. So this means when we put together our final answer for the equation, we would have something like this, and then here's where the answers would vary. I would expect everyone to have an A value of 10, a B value of pi over 10, and a K value of 0. What would differ in each person's equation is their H value. So I could write an H value of 5. Somebody else could write an H value of 25. And then as far as identifying the reflections, when you're writing the equation, you don't ever have to reflect it if you can always find a starting point that we were just talking about. However, the time where you would see possibly a reflection is, let's say I identified this as a good starting point because it's still on the midline and it goes through the points like a parent sine function. But notice it goes through the points like a reflected parent sine function, because instead of going upward first, it goes downward first. So if somebody chose this h value, which is -5, they would also have a reflection. So their equation would still have 10 as the a and pi over 10 as the b, but if they chose -5 as their h, they would also have a reflection vertically in their equation to change that wave from going upward first to going downward. It's reflecting it over the x-axis. Now, if you were writing a cosine for this equation, everything would almost be exactly the same. The amplitude is still the same. The period is still the same. Again, it's that h value that would change, and that's based on a different perspective than it was before. That perspective is that the cosine graph, the cosine parent function has that max value, midline, minimum, midline, maximum. So it goes like this, and we think of this more of our starting point. So a place where I see that on my graph could be here. And from maximum to maximum looks like one cycle of the cosine parent function. And then if I choose that, I would choose this kind of starting point, which is happening at 10, and then I would have x minus 10. However, I could choose a starting point over here, because I could again see this as one cycle of the cosine parent function, and then that h value would be 30. So another way someone could write this is to put in an h value of 30. Or they could choose a minimum starting point down here at 20, and they could be viewing kind of this as one cycle of the cosine graph, which it is, but that, because it's starting at the minimum instead of the maximum, has been reflected. So if they chose 20 as their h value, they would have to make an a value negative to show that reflection. We're also going to look at number 25. So this, for those of you that are looking at this was from our Skill 2 homework. And I was focusing specifically on 45 with a little extra explanation about h values. And Skill 3 focused more on tangent graphs. So I'm going to talk about that real quick, specifically number 25. The equation for that was y equals tan negative theta. So I'm going to address this two ways. One way is with knowing your sketches really well and the patterns of the graphs. The other way is with the points. So if you know what tangent look like, which it is your job to know those parent functions really well, it has a period of pi, which means we're generally looking at fourths, splitting up the graphs. And the cycle it followed was the midline point, the point above, which in our parent function is 1, the asymptote, the point below, and then back to the midline. So it kind of looked like this. But overall, once you fill in the rest of those cycles in that picture, it ends up looking something like this. Just so you get an idea of how it looks. So the only transformation that's happening in this graph is this negative, which is a reflection. And remember, when it's addressing the x value, which in this case theta is like your x value, changing x values actually flips the graph over the y-axis. So what's going to happen here is that each of these points you plotted is going to reflect over the axis. So that one will stay at the origin. The point that was here is going to end up over here. So the reflection of that graph that you see will go like this. See how it looks like it's reflection over the axis? The asymptote that was along here will now be here. This point will be here, and this point will be here. And you will see something like this. So one way to answer this is that I can see the scale or nothing else changes because there's no compressions or stretches or stuff like that. So this is still by pi over 4, and there's still vertically 1 and -1 where my points are going. But now I see this sequence of points here and then here with an asymptote here, and then down here and back here. And then if I continue that cycle, this would be up here and there would be another asymptote here, or the other way. And that would be one way to answer it. The other way to get the points is to use actual points from the graph like we have previously. So if you like doing that, this is the parent function that I have memorized for the tangent. And if I do the transformations, because all I have is the reflection over the y-axis, the x values having that negative value, this would be my chart. So when I go through and apply that negative, here's what I'm seeing. The y values are unaffected. And these points are what you see over here on the graph: 0, 0, negative pi over 4, 1, negative pi over 2 is undefined, negative 3 pi over 4, -1, negative pi 0, and you'll see that cycle, but then I finish it by completing the periods of the graphs in each direction so I can see 2 full periods of that function.